Hey guys, these are the notes for 2.1. This focuses on parallel and perpendicular lines. Um, so our first thing we're going to do is define a couple angles, types of angles. Some of them you already know, but I'm going to re-go over them. So the first one is adjacent angles. Adjacent angles say two angles that share a common vertex and a common side and don't overlap. Okay. So, what do I mean by this? This would probably be helpful with an example. Okay. And then say we label our four angles, one, two, three, and four, right? What are adjacent ones? Well, essentially, they are angles that are right next to each other. So if you see, right, angle one and angle two, angle two, right? How they're next to each other. Angle one and angle four, angle two and angle three, and angle three and angle four. So essentially, you can think of angles touching. Okay, which is like the opposite of vertical angles because we know vertical angles, right? They're not touching. Okay, they don't have a same side, a shared side. Now, the next one is a linear pair of angles. So we know what linear pair is, right? A linear pair makes that straight line. So just the formal definition of linear pairs of angles is the adjacent angles formed by two supplementary angles. Okay, so right, we have angle. Say we have angle one and angle two. Right, we know that angle one and angle two are a linear pair because they create a straight line. The next one is supplementary angles. Right, we just used supplementary angles in the last definition, but hopefully you remember it's two angles whose sum is 180 degrees. Right, because we know a straight line is 180 degrees, and all linear pairs are supplementary. Okay, so right, I'll give an example of supplementary and not supplementary angles. So say we have a 30-degree angle right here, and then we have a 150-degree angle. Right, we know it adds up to 180. Right, it's a linear pair and it's supplementary. Okay, so this is not supplementary. This next one, so here we have a 40-degree angle, and we have 140, but they're not right adjacent angles. Because they're not adjacent, that means they are not linear pairs. Okay, but they are actually supplementary. So let me just erase that. They're not linear pairs, but they're supplementary because they add up to 180 degrees. So again, they're not linear pairs, but if they add up to 180, that makes them supplementary angles. All right, so the next one is vertical angles. You guys should be pretty familiar with vertical angles. We've gone through them a good amount of time. And I'm just filling in that the first one is a linear pair because it's adds to 180 degrees. It's supplementary, and they are adjacent angles. Therefore, they make a linear pair. But again, back to vertical angles. We've gone through them. Um, right? Vertical angles are opposite angles formed by two intersecting lines that share a common vertex, but have no common sides. Okay. So they also all vertical angles are congruent, right? So we should know this, right? They are all congruent, meaning all their measures are going to be equal as well. So we can draw a couple lines to create some angles, and we can figure out which ones are vertical angles. I'm not sure why the lines went away, but I'm going to redraw them. And then I'm going to mark that angle AGC, so this one right here, right, is a vertical angle with angle DEF. Oh, sorry, DGF. I'm sorry about that. Right? And they are vertical angles because they, again, share a same vertex, which is G, and they have no common sides. Okay, we know they are congruent, right, because they are vertical angles. All right, so now we're going to go through a couple theorems. So this first one is the same side interior angles postulate. Okay, it says if a transversal intersects two parallel lines, then the same side interior angles are supplementary. Okay, so first we'll start. What is a transversal? Okay, a transversal is a line, right, that cuts or passes through two other lines. Okay, and this is at distinct points. Okay, so if we look at same side interior angles, right, we can point out where the transversal is, right? We have two lines, and then we have one line going through both those lines at distinct points, right? So that line right there is what we call a transversal that I just drew the arrow to. All right, so we usually mark this transversal with just a T. Usually it's cursive, but uh, it's fine as long as you kind of make it like a wavy looking T. But so that's how we label our transversal. And then we can label the two lines as well with lowercase letters. So if we can mark our first one as line L, and then second one as line M. Okay, so we know that in this line L and M are parallel. That's what those two lines mean. That means they're parallel, and we know this because it says if a transversal intersects two parallel lines, right? So L and M need to be parallel. And you can see that with the little red arrows on the picture. That means parallel. All right, now it says the same side interior. So interior means inside, right? L and M, inside the two parallel lines. Okay. We can also mark the other angles as like 3 and 4. Okay, so those are the other two angles in the interior of L and M. Now, this says same side, right? So if you think of same side, what you're going to think of is you're going to think of on the same side of that transversal. Okay, so same side of the transversal, right, would be angle 1 and 2, right? They're both on the right side. So they are same side and interior, and they are supplementary angles because they are same side interior. Okay. When we know that supplementary angles mean the two measures added together equal 180 degrees. We could also say 3 and 4, they're both on the left side, right? So they're also on the same side, right? Therefore, those are also same side interior angles as well. All right, so those are same side interior angles. Next, we have alternate interior angles theorem. This one states if a transversal intersects two parallel lines, then alternate interior angles are congruent. Okay, so these case we would have congruent angles. Right. So again, we're going to look through our transversal, right? And right when we think of the word alternate, what we're going to think of is opposite sides. So remember, same side means right either both on the right of the transversal, both on the left, and then alternate means one's on the right and one's on the left. Right? They alternate sides of the transversal. Okay, so if we remark our lines T, L, and M, right, and we look at our T, right, we can see angle 1 and angle 2 are on opposite sides, so they are alternate. Okay. We also know that if they're interior, that means they're both inside L and M. Right? And we can also see angle 1 and angle 2 are in the inside or interior of L and M. Right? So we have interior angles, and then we also have alternate angles because they're on opposite sides of our transversal. Right? So we can mark them with little arcs to tell that they are congruent because our theorem tells us that they're congruent. And our conclusion would be angle 1 is congruent to angle 2. And again, this is because, right, they're on opposite sides, meaning alternate. Right, they're on opposite sides of T, and right, they're interior because they are on the inside of L and M. Right, and that's why we can say they're congruent. All right, so our next two sets of theorems are corresponding angles theorem and alternate exterior angles theorem. All of these theorems are dealing with two parallel lines that are intersected by a transversal, right? So T, and then our parallel lines are L and M again. Okay, they can be other letters, but I like to use L and M. Now, corresponding angles tells us that if transversals intersect two parallel lines, then corresponding angles are congruent. When you think of corresponding, you want to think the same spot on the other line, right? So the other parallel line. So, right, you want to find the location of the intersection of L and T and the location of the intersection of M and T, right? So if it's in the top left of intersection of L and T and it's in the top left of M and T, then, right, that makes them corresponding angles, right? The intersections are those black dots I just made, right, where L and T cross and M and T cross, right? So if they're in the same spot or same location for the intersection, then they're corresponding angles. And this tells us that corresponding angles are congruent. So you want to kind of see which spot they lie in, right? And if they're on the same spot on the other parallel lines at its intersection, right, we can say they're congruent. So I'm going to mark them with the arcs and say that angle 1 is congruent to angle 2. And they are because they are on the top left of the intersections with the transversal. Okay. So they're congruent again. So angle 1 is congruent to angle 2, right? And that means their measures are equal as well. Right? So that's what corresponding angles theorem goes through. Okay. The next one is alternate exterior angles theorem. What the alternate exterior angles theorem says is if a transversal intersects two parallel lines, then the alternate exterior angles are congruent. Okay, so we should know what alternate means, right? We went over alternate before. Alternate means opposite sides of the transversal. All right, so first we want to see if they're on the opposite sides. Now we went over what interior means. It means in between the two parallel lines. Well, exterior is going to be outside the parallel lines. Okay. So you can see outside on the top and then outside on the bottom, right? So there's two places where it can be outside, only one place where it can be inside, right? So we have our transversal T, right? And we want to see if they are on opposite sides of T because they're alternate, and then on the outside of L and M, right? We can see that they're both on the outside, and they're both, one's on the left side, the one is on the left side, 2 is on the right side, so we can mark them as congruent because alternate exterior angles are congruent. Okay, so angle 1 is congruent to angle 2. And I'll reiterate it, it's because it's outside of the parallel lines, and it's also on the opposite side of T. Those are like little definitions of each of these theorems, kind of little hints you can think of. All right, now in this example, what we're going to do is we're going to use those theorems that we went over before and look at a problem and look at the angles and figure out which go with corresponding angles, which go with alternate interior, and which goes with alternate exterior. Okay, so I'm going to start my corresponding angles using the red. Okay, so if I look at 1, angle 1 is corresponding the same, remember, same spot. That's what you want to think, but opposite, but the other parallel line, right? So angle 1 is corresponding to angle 6. If we look at 2, angle 2 is in the top right, so that's corresponding to the top right of M, which is angle 5. Next is angle 4. that's on the bottom left of L. So bottom left of M is angle 8. And lastly, angle 3 is on the bottom right, so that corresponds with angle 7 on the bottom right of M. Okay, so that is when we find corresponding. Right, remember, same side, same spot, sorry. Alternate interior, so inside and opposite. Okay, so inside 4, right, the opposite, we know our congruent is 4 and 5. So angle 4 and angle 5 are interior and opposite, and also angle 3 and angle 6, right? And we know these are all congruent. Okay, same with corresponding angles are all congruent. The last is alternate exterior angles. So again, say we look at angle 1. Alternate means opposite. And an exterior means the outside of both the parallel lines. Again, these are congruent as well. So angle 1 and angle 7 are on the opposite and outside, as well as angle 2 and angle 8. Okay, so these are 3 of the theorems where we are given that they are congruent, right? And we can mark them and make sure you use your little hints like opposite or same side, and then inside and outside, right, in the same spot. Okay, so we have those little definitions that help us out. Okay, so in this example, it says, how can you express each of the numbered angles in terms of x? So we're going to look 1, 2, 3, 4, 6, 7, and 8. And we're going to figure out the relationship to this x and whether they're congruent or equal to each other, or they are supplementary. Right? Those are 2 ways, right? So we want to look if, right, they're corresponding. Alternate exterior angles. If they're alternate interior angles, or vertical angles. Okay, so we should know, right, that corresponding means congruent, alternate exterior means congruent, vertical angles mean congruent, right? And same with alternate interior angles, right? And then also, right, they could be supplementary, right? So those are all congruent ones. Now, they could be supplementary, which means adds to 180, right? And that's if we have, right, a linear pair or same side interior. Right, so we are gonna apply x to 1, 2, 3, 4, 6, 7, and 8 and figure out whether they're congruent and whether they are supplementary and they add to 180 degrees. Okay, so we can start with angle 1. So 1, right? 1, they are corresponding. Right, 1 and x. So therefore, measure of angle 1 is equal to x degrees. Angle 2, they're same side interior. Right, because they're both on, so n is our transversal. And then L and M, you'll most likely see L and M most of the time for your parallel lines, right? So if they're same side interior, that means they're supplementary, right? So that means they add up
So measure of angle 2 plus x degrees equals 180 degrees. Number 3, angle 3 is on the opposite side. So x and 3 are on the opposite sides of the transversal, right? So that means alternate. And they are on the interior, so they're alternate interior angles, meaning they are congruent. So measure of angle 3 is equal to x degrees. 4. So if we look at angle 4 compared to x, one's interior and one's exterior, and they're on opposite sides. Now, if we kind of look at their angle measure, right, one's going to be an obtuse, and one is going to be acute, right? X is acute, 4 is obtuse, right? We don't have an exact way to find this, but what we can do is substitute things out, right? For number 4, right, we know angle 4 is congruent to angle 2 because they're vertical angles. And we said for angle 2, they are supplementary and they add to 180, right? So we can substitute, right, use substitution to say that measure of angle 4 added to x degrees equals 180 because we know angle 2 and angle 4 are congruent, right, because they're vertical angles. Okay, so that one we had to use a little extra things, but you can kind of tell if one's acute and one's obtuse, they're going to be a linear pair and they're going to add to 180 degrees. If they look almost like the same measure, like 1 and x, most likely they're going to be congruent, but we just have to prove it. All right, so number 6. Number 6, same thing, right? So we don't have an exact thing for them, right? They're next to each other, but we do know they make a linear pair. So that is one thing. And if we have a linear pair, they're supplementary. So we can add the measure of angle 6 to x degrees, and we get 180 degrees because they're linear pairs. 7, they're vertical angles. That means they're congruent, right? 7 and x, here and here. So measure of angle 7 is equal to x degrees. The last one is 8. Again, it's like 6. We have a linear pair, which means they're supplementary and they add to 180 degrees. So those are your two options. They're either equal or they add to 180 degrees. You just got to figure out which is which for these. All right, so for this section, I'm not going to ask you to prove statements, but I kind of want to go through these just to kind of reiterate some of the definitions and the postulates and theorems that we went through and kind of show you a proof to kind of go back to 1.7. So I'm going to kind of go through this quickly. But right, our first is always the given. M is parallel to N. Those are our parallel lines. Right. And then we want to prove angle 1 is congruent to angle 2. Okay. So we can state a couple things, right? So we could say angle 1 and angle 3 are same side interior. Right, because right, we know same side interior is same side inside the two parallel lines, right? So this is just definition of same side interior angles. We know because they are same side, right? Their measures are going to add up to 180 degrees. Right? We know same sides are supplementary angles, right? So we know this because of the same side interior postulate, angle postulate. cannot spell. All right. Now, right, we also know that, right, 2 and 3 right here make a linear pair. Right? So we could say measure of angle 2 plus measure of angle 3 equals 180 degrees by the definition of a linear pair, right? The linear pair theorem. Again, I'm not going to ask you to prove something like this. I'm just want to go through it just to remind us what each theorem, postulate, and definition means. Okay. Now, right, we can use our substitution. Right, we have some things we can substitute in. We can say, right, the measure of angle 1 plus the measure of angle 3 from our statement 3 is equal to, because they both equal 180, we can substitute them in, measure of angle 2 plus measure of angle 3. Right, and that's by substitution. Or, right, it could also be the transitive property, right, either one. Then, right, we can subtract measure of angle 3 from both sides, right, and we get measure of angle 1 equals the measure of angle 2, right? And this would be our subtraction property of equality. Right, and then our last step, right, we know that congruent angles, right, the definition of congruent angles tells us that if their measures are equal, then the angles are congruent, or vice versa, the angles are congruent, the measures are equal. So we can state angle 1 is congruent to angle 2, right, by the definition of congruent angles. Right, and that's how we prove this alternate interior angles theorem. But we do know that before we went over it, we didn't need to prove it because it's already a theorem. But this is just going through, is kind of reiterating things from 1.7. But don't worry about solving anything like that. This last problem, it's kind of like a picture word problem, but essentially what it is multiple lines, and we're trying to find the transversals and parallel lines in it in order to find the measure of the missing angles given an angle measure. Okay, so it says the white trim shown for the wall of the barn should be constructed so that AC is congruent to EG. So, right, AC is, sorry, not congruent, I mean parallel, right, to EG. We also have JA. JA is congruent to HB. I'm just drawing them in different colors. And then we also have JC. So is congruent to KG. Okay, so we want to find the angle measure of angle 1. Okay, now, right, what I'm going to do is we can actually pull out from the picture, right, angle 1, and we know our angle is 68 in here. Let's pull this out, right? Keep it red, right? For angle 1, we're using the transversal, right, JA. I mean the parallel line JA and parallel line HB. And then we have the transversal AC going through it. Okay, so this is AC. Now we're given this is 68 degrees, right, from right here. And then this is angle 1, right? If we look at angle 1 and 68, right, angles, angle 1 and 68 degrees are same side interior angles. right? So they add up to 180 degrees because they're supplementary. So therefore, the measure of angle 1, right, is just 180 minus 68, right, which gives us 112 degrees. So it's probably easier to kind of like break out the drawing for each one of these. All right, so then angle 2, right? Angle 2, right? We also are using our angle 2, we're using JA again. But that is our transversal, and we're using the two parallel lines EG and AC. Okay, so right, we know right here we have 68 degrees. Right here we have angle 2. Okay, so these are both right in the bottom right of our two parallel lines. So if then they're bottom right, then angle 2 and 68 degrees, they are corresponding, meaning they're equal. So measure of angle 2 is equal to 68 degrees. So I know it's tough with the picture, but it's easier when you pull them out, just the two parallel lines and the one transversal that contains the two angles you're looking at. Okay. And our last one is angle 3. Okay. Angle 3, right here, we can use right angle 2 to help us out if we want. All right. So say I pull out this EG. Right, and then we have the two parallel lines, AJ and BH. AJ, BH. Right, and then we have 2 here and 3 here. All right, so we know 2 and 3, angle 2 and angle 3. They're both in the bottom left of the two parallel lines, so they are corresponding. And that means they're equal. So measure of angle 2 equals measure of angle 3. And we know from right here, measure of angle 2 is 68 degrees. So measure of angle 3 is 68 degrees. All right, so I know this is a little tough with the picture, but if you can pull out the exact parallel lines in the transversal that use the certain angle that you're looking for, it's much easier. Okay, but this is the end of the notes. Let me know if you have any questions. Either email me, Google Classroom, or on Remind.